In this video, I am going to explain RC series circuit. Consider one RC series circuit which is supplied with an alternating voltage of V volts. A current of I amperes starts flowing in this series circuit, because of which a voltage of VR drops across the resistor. The voltage drop across the capacitor is Vc. By Ohm's law, we can write VR is equal to I into R. Also, Vc is equal to I into Xc. The total voltage V applied across the series combination is the addition of VR and Vc. So, we can write VR bar is equal V bar is equal to VR bar plus Vc bar. This is a phasor addition. In order to find out the total voltage V bar, we need to draw a phasor diagram and add VR bar and Vc bar. Let us draw a phasor diagram for this. Here, current is common to both resistor and capacitor. So, we will consider current as the reference phasor. For resistor, the voltage across resistor and current flowing through resistor, they are in phase. So, we need to draw VR along current. For capacitor, the current flowing through the capacitor leads the voltage across capacitor by 90 degree. So, we will have to draw Vc such that current leads the voltage by 90 degree. This is Vc. Now, we have to add VR and Vc phasors. For this, let us draw a parallelogram. The diagonal of this parallelogram will give us the total supply voltage. This is V bar, which is equal to VR bar plus Vc bar. The angle subtended between voltage phasor and current phasor is angle phi. Here we can see that current is leading the voltage by an angle phi. So, power factor of the circuit is leading. Here a triangle is formed with sides VR, this is Vc and this is V. Let us draw this triangle again. This triangle is called as voltage triangle. This side is VR, the vertical side is Vc and this is V. This angle is angle phi. If we divide all the sides of this voltage triangle by current, we get a similar triangle. Let us divide each side by current I. If we divide VR by I, we get resistance R. If we divide Vc by I, we get Xc. If we divide V by I, we get impedance Z. So, we can write the equation of this impedance Z as Z is equal to R minus J Xc. Xc is along negative y-axis, so we have written minus J Xc. This is impedance Z. Impedance is nothing but the total opposition in this RC series circuit. This form of representation is the rectangular form, and in polar form we can write Z as Z is equal to mod Z at an angle phi, where mod Z is the magnitude of impedance is given as mod Z is equal to under root of R square plus Xc square, and angle phi is given equal to tan inverse of minus Xc upon R. Here in this phasor diagram, we can observe that the current is leading the voltage by an angle phi. If we consider that voltage is reference and we write the equation of V as V is equal to Vm sin omega t, we can write the equation of I, which is leading this voltage by an angle phi, as I is equal to Im sin omega t plus phi. Now let us derive the expression for power consumed in RC series circuit. For this, we need to refer to the waveforms of voltage and current in RC series circuit. Here, it can be observed that the voltage waveform starts from theta equal to 0, whereas the current is leading the voltage by an angle phi. So, this current waveform starts from theta equal to minus phi. It can be seen that from an angle of minus phi to 0, the power is negative, whereas between 0 to pi minus phi, the power is positive. From pi minus phi to pi, the power is again negative. From pi to 2 pi minus phi, power is positive, and between 2 pi minus phi to 2 pi, again the power is negative. The average power is shown by this dotted line. We have to find out the mathematical expression for this instantaneous power and the average power. P instantaneous is given equal to the product of instantaneous voltage and current. So, P instantaneous is equal to Vm sin omega t into Im sin omega t plus phi. This is equal to Vm Im into sin omega t into sin of omega t plus phi. This is equal to Vm into Im cos of minus phi minus cos of 2 omega t plus phi whole divided by 2. So here we get two terms, in which the second term is a cosine term with double frequency component. Now when we want to find out the average value of power, we need to integrate this instantaneous power equation over a complete cycle. And here the integration of this second term becomes 0. So P average will be equal to Vm Im cos phi upon 2. This can be written as Vm upon root 2 into Im upon root 2 into cos phi. Vm upon root 2 is Vrms, Im upon root 2 is Irms into cos phi. So P average is equal to Vi cos phi.